Hello everyone, my name is Will Robertson and I am an education specialist assigned to the Marshall Space Flight Center in Huntsville, Alabama. Welcome to Summer of Innovation 2011. For the next few moments I would like to share with you an activity or two that can be used within the How Does Earth Compare lesson, and it's a scale modeling activity. And this lesson is part of the theme Earth and Space Science, and is part of the planetology unit. And the activity again that we will be using or to be talking about is exploring planet sizes. You know, as students and even grown-ups for that matter, many times we have a hard time visualizing exactly how big one planet is compared to the other. Take the case of the Earth here. We really don't understand or appreciate how big the Earth is because, you know, we're only seeing one part of the Earth where we are. So to have an appreciation as to the scale of the Earth, you have to compare it with something else, and you have to make a model. So that's what we're going to be doing. So what you do is to collect a rubber ball or two, preferably one that's blue to represent the Earth, and another one half the size to represent Mars. Well, it just so happens if you have your students find the diameter of the planets of the solar system, they will see that the Earth has a diameter that's approximately 12,500 kilometers, and that Mars has a diameter that's approximately 6,500 kilometers. So again, you will see very quickly that Mars is half the size of the Earth. Now, you can explain this to them or tell them this, but they really need to see it so they can visualize it better. And you can add the size of other objects in the solar system, for example, the Moon. If you want to show the size differences or the size difference between Earth and Moon, you make another scale. Well, it just so happens that the Moon has a diameter that's about 3,500 kilometers, which turns out to be about 3.5 to 4 times smaller than the Earth's diameter. And if you do the activity of finding the diameter of a sphere by using pi, in other words, if you take your the rubber ball that you're using to represent the Earth, have your students measure the circumference in centimeters and divide it by pi 3.14, and they will see that in this case, which I've already have pre-measured, the diameter here turns out to be about 6 centimeters in diameter. And if you take a fourth of that, it comes out to be about the size, a little bit more than a centimeter, and that's about the size of this marble here. So what you're looking at is the true scale relationship between how much smaller the Earth is, or how much smaller the Moon is compared to the Earth. So again, it's one thing to tell students, for example, that the Moon is 4.5 times smaller than the Earth, but you know, they really need to see it. And you can do this with all the planets. Now, what you would want to do is to do the whole solar system to scale. And I would encourage you to go to the NASA NEON website. NASA NEON is the online learning community that's the NASA Educators Online Network. If you go to NASA NEON, register first and then go to the different groups that's posted to get other lesson ideas, but specifically go to the East Tennessee State University group. And I have posted on that group an activity that builds upon what we're talking about here that's referred to as planets to scale activity. And there's a informational sheet that you can download that maps out the different sizes of balls to collect or spheres to collect to represent the planets in the solar system. So another activity I want to encourage you to do as part of How Does Earth Compare is walking the planet distances. You know, the problem with textbooks and the problems with web pages when they show the solar system to scale as far as distances, they cannot do it because you're limited to the size of the page and limited to the size of the website page. So this activity, walking the planet distances, you can go outside, and the lesson actually tells you how to incrementally walk out the distances between Mercury and Venus, Venus and Earth, and so forth. Now, one thing I also want to mention to you is once you have the planets lined up, don't do it like you see in this slide here. At no particular time do all the planets line up in a linear fashion that you see here. So once you map it out, have the students represent the planets as they walk this out, and have it in a great concentric circle idea where you have the sun and then maybe Mercury at one place and Venus at the other place and Earth and Mars. Again, this will allow the students to have a real good visual as to the vastness of the solar system. Okay, well, I hope you will take these ideas and incorporate in How Does Earth Compare lesson, and stay tuned for other videos that can be used in conjunction with Summer of Innovation 2011. Thanks for joining me.